graphic of them up here. Here they are. Squeeze out a little bit so we can see them better. Now what I want us to do is I want us to solve these equations without actually doing the algebra. I want to train you guys how to be able to look at graphs and what you're seeing in the graph. I've also included this graphic on your quiz for Wednesday. With different equations to solve. So what I've done up here, turn over the lights here. What I've done up here, there, just one, make it a little bit brighter. Blue line, notice it's got arrows on the right and left sides, is the graph of the line y equals x plus 8 over 3. The green line is the graph of the line y equals 2 times the quantity x plus 1. Let's ask some review-ish kind of questions about these lines. Pick color, blue or green?
Blue.
Blue it is. Blue heard blue first. What is the slope of that blue line? A grade is equal to something called slope. We're going to start talking about it today. So what is the slope of that blue line? Let me see hands on this one. Let me see hands once you've got a... If you want to answer. If you want to answer, let me see hands. And then we'll get the answers. Tell me your name right there.
Taryn?
Taryn, go.
I'm going to guess. I think it's 1/3.
She thinks it's 1/3. Tell me your name right there with purple shirt.
Will.
Will says yes. We agree. We agree. We agree. Randall's. Why is it 1/3, Taryn?
Because you look at the X. Oh gosh, I don't know.
No, go ahead. Go with that. I wasn't thinking what you were thinking. You look at the X.
And it's over 3. So
So Taryn's going to the equation of the line y equals mx plus b, which probably a bunch of us have learned back. So you're taking it back to y equals mx plus. I'm assuming this is the form you guys learned it, and I'm guessing you did in your previous lives as math students. Y equals mx plus b. So your slope is the coefficient on x. You said I looked at x. The coefficient on x. Good. Now the coefficient on x is 1, but Taryn knows that this divided by 3 is part of that. So when you divide this whole thing by 3, it has to go to both pieces. So 1 over 3. Good. Very, very nice. Anybody do it a different way? Without the equation at all. Could you pull the slope off the graph without even using the equation? Yeah. Tell me it one more time. Carrie, that's right. Go. How'd you do it?
I found where they intersected.
Oh, good. Right here?
Anywhere. And then find where they intersect again.
When you say they, what do you...
Where the line intersects.
So they only intersect here once.
Yes.
So now, what's the other thing you're using?
I followed the blue line.
Okay.
Where they intersect again on the graph at a perfect
the Y and
place.
X intersect.
Yes.
Oh, so like this point here and that point there.
Yes.
Oh, okay. So this point here and that point there. Oh, okay. I'm sorry. When you say they, I go with green and
Sorry,
blue.
yes.
That's okay. So how did you get the slope from that?
And I count up 1,
Okay, so 1.
and then over. 1, 2, 3.
Ah!
No.
Rise.
Rise up row.
Run. Rise, run. Good. This is actually part of what the back half of today is all about, is this basic idea of rise and run. Good. So since you rose 1 and you're running 3, you get the same 1/3 that Taryn got with the equation. Very nice. Can you see where the y-intercept is now by doing it this way? Can you see where the y-intercept is? I labeled it right here. What is that guy right there? What number is that?
8/3.
Say that again. I heard 8/3. 8/3 for sure. Also, a little bit more than 2.5. Somebody said a little more than 2.5. I thought back there, right? It's 2.67. It's that same magical 2.67. It's 8 over 3. We saw it earlier today in a different context over there. Good. Good. So what you're looking at right there is just a linear equation. Every point on that line, no matter where it is, will satisfy that equation. If you find a point on this line, find its x value, stick it into that, it'll kick out its y value. And vice versa. If you find its y value, it'll pop out its x value. Very, very good. Same with the... Oh, please, go!
Do you mind showing me how you got y equals mx?
I didn't really get it at all. All I did was, this is, I'm assuming, the form you guys learned in your last algebra class. I could be wrong. Maybe it was a different one you learned.
No, we learned that.
So basically,
Kind of.
the idea is, this is the, in my opinion, the simplest form of a linear equation. If you have the slope and you've got the y-intercept, then you've got an agreement between the points on this line and their relation to each other. So in other words, this one would be y equals 1/3 x plus 8/3, if you split the fraction and made it looking like that. So it's not so much I didn't derive it, it's just you can write it in that form if you needed to. How about the green one? What's the slope of the green one? Please. -2. Why? Because it is. That's a good answer. Because it is. Can we do the rise over run thing again? I kind of like that. Carrie did earlier. Can we do the rise over run? Right? Pick a point. There's a point. Rise. Run. I mean, what do you think it is? What's this rise? Careful. It's negative, isn't it? You're dropping. It's a -1. And then what's this run? There are 3 answers within 3.5 seconds. I heard 1, I have 4 answers. I heard 1, I heard 2, and then I heard a half. I heard 1, then I heard 2, then I heard a half. Michelle?
-2 and.
Oh, you're saying forget this.
Yeah.
Why would you go there when you can come here and then to there? Does that make more sense? Is this wrong? Is that wrong?
Small pieces.
It's right, it becomes an incremental piece and it might be hard to see where that's crossing. Is that a half? Well, as it turns out it is. As it turns out it is, because when you go down 2 and over 1, you're back on the exact coordinate. So this one, if you go half as far here, you have to go half as far that way. So yeah, it is the same, but it's easier to pull the number this way. So the slope, what's this guy right here? The rise is -2. And the run is +1, which means the slope is -2 over +1, which is -2. Which you can actually see right there. -2 times x gives you -2x. Where's the y-intercept on that thing? Can you see where it hits the y-axis? Right there at -2. In which, again, if you multiply that out, you'd see a -2 there as well. Beautiful. Beautiful. Good. File that slope into the back of your mind momentarily. We'll come back. That's what I want to do in about 15 minutes when we get into grading. But what I want to do right now is utilize just this graph to solve some equations. Look at the first one at the bottom. It says 0 equals -2 times the quantity x plus 1. Now, you can totally solve this manually. You could totally solve that using the Lego method. Absolutely. Absolutely. I'm not saying you can't. I'm saying you can also solve it. You can also solve it right here using the graph. It's asking, where does -2 times the quantity x plus 1 equal 0? That's the equation you have to solve. So if you compare that to the equation just above that it resembles, the right-hand side of this thing is identical, exactly the same. What's the left-hand side? What has become 0? Y has become 0. Where does y equal 0, friends? On this coordinate plane, I'm doing a bit of a review here with the plane too. Where does y equal 0? Right here?
-1.
Okay, a bunch of you are answering a very specific question. I mean a general answer. Is this where y equals 0?
Yes.
Are we sure about that? Because I happen to look up when I asked the question, are you sure? Right there, y equals 5. And right there, y equals 4. And right there, y equals 3. And right there, y equals... Oh, here it equals 0. So here, y equals 0.
It's the x-intercept.
Does it equal 0 anywhere else? No, you're answering too specific a question, Terry. I mean, in the coordinate plane, where does y equal 0? You're answering too specific a question for me. Hold that thought. Hold that thought. Y equals 0 here. Does y equal 0 anywhere else?
Yes.
Where?
-1
-1.
at x.
Ah, when x equals -1. Does y equal 0 anywhere else? Anywhere else on the x-axis. This is the x-axis, yes? That's where y equals 0. As you move up and down from that with horizontal lines, As you move up and down from that, you get other y values. But that's where y equals 0. So this line right here, if you take a green marker and trace it out, you are tracing everywhere. Sorry about that. That y equals 0. So this point here is 0, 0. It's the origin. 1, 0, 2, 0, 3, 0, 4, 0, and so forth. It's great. It's fantastic. Where does negative 2 times the quantity x plus 1 equal 0? Without solving it by hand. Without solving it by hand. Don't distribute that 2 in or divide by negative 2 or anything like that. I want to use that green line, which is this guy, and the fact that this right here is where y equals 0.
Negative 1.
I hear some votes for negative 1. This guy right here. Now, how can that be the case if we didn't actually solve this equation manually? How could this be the case if we didn't solve the equation manually? Tell me your name.
Allie.
Allie,
But
go.
That's where it lands on the x-axis, so it's always going to be 0 because it's not going up or down.
So we know that everywhere on this line, y equals 0. And we know that everywhere on this line, y equals negative 2 times the quantity x plus 1. So everywhere here is where y equals negative 2 times the quantity x plus 1. And everywhere here, y equals 0. Everybody follow me so far? So the point where those two intersect has to be the place where both y equals negative 2 times the quantity x plus 1 and y equals 0. So in other words, the only place this is true is where both of those individual cases have to be true. You don't have to solve anything. You can solve it if you want to. You can divide by the 2 and subtract the negative 1, subtract the 1. But if you analyze it this way, you don't need to solve anything. You've actually solved it. You just didn't solve it numerically. You solved it graphically. Here is where y equals negative 2 times the quantity x plus 1. Here is where y equals 0. You see that y right there? That y right there and that y right there are the same y. If 0 equals y and y equals that, then 0 has to equal the negative 2. There you go. Let's take 5. Let's take 5 and do the rest of these equations just like that using the graphs. Just like that using the graphs. I need you guys to be better graph readers. If this is not making sense, we're going to make it make sense. We're going to make it make sense.